Spark is just that it's an in-memory database. So Spark is an in-memory database. And then the next thing is like why, or like what are the benefits of this? So this allows, the primary reason is just like for quickly searching through a lot of data. So by being in memory, it just allows it, one, it's just faster, right? Faster than reading things from disk. And then two, it allows for like high, like computations that require a lot of memory, right? So that would be, certain like ML, some like data analysis, right? We talked about the fact that, I think we did at least, that like if you try to use pandas to like even search through maybe like a few thousand, like 5,000-10,000 rows, you're gonna quickly see how slow it is. Like it will be obvious. So that it will just be painful to simply like sort the data, something like that, right? So you can then use like a pandas equivalent with like the Spark interface by using PySpark, and it will be faster for you to do this, right? It has other optimizations, right? So being cluster based. So how is it fast by being cluster based? Essentially by performing map reduce, right? Using a map reduce strategy, right? Whereby it simultaneously queries partitions of the data set and then combines the result, right? And this is the same thing. Like we've seen multiple, like Redshift, right, uses MapReduce. Snowflake, if you employ like multiple computes, will also use MapReduce, right? They just divide and conquer is essentially MapReduce. Split it up. Each kind of compute gets its own segment or partition to query, and then combine back the results. And then the other thing we saw was just like lazy execution, meaning that like how does it help with that? Well, basically it can see. It waits until the very end of the query to perform it. That way, before it performs the query, it can determine what is the most efficient way to give you back what you're ultimately asking for. And we gave an example with like, remember the take two, right? Where it's like, oh, I don't have to query everything because you just want the first two results anyway, right? So, the fact that it waits until the action is called, right, until it kicks off the Spark job. And then remember, we saw underneath with like the DAGs, right, the various stages to each job, how it will determine a good strategy for retrieving the results. How does Spark achieve fault tolerance? Remember with like that resilient RDDs section? So for this, I'd say the way I would answer this is the typical kind of strategy with other databases is to kind of make a copy of the data. Spark does not do that. Instead, it keeps track of the transformations of the data, tracks the transformations to get from one RDD to another. If a node goes down, then we'll reproduce those transformations, right? And then a consequence of this, remember, is because you only get coarse transformations, meaning have to act on the entire data set. And then two, the RDDs are read-only, right? Why does this, how does this relate to this fault tolerance strategy? Well, coarse transformations means it doesn't have to keep track of every little change. Like I'm just changing this one record over here, right? It reduces that because the only transformations you're really allowed are on the entire data set. So it just has to remember, can remember things a little bit more broadly. And then same thing, RDD, read only. These kind of go together. Like if it's like, oh, I separately changed this row, now I have to remember that you made this this one little change. We don't have to do that. It's just, here's the starting RDD, here's the various steps that were applied, and that will take me to the ending RDD. All right. So this is effectively what we covered in the last class. Questions about this before we move on?
I haven't read the resilient part yet, but do the RDDs persist after it gets the job done? So all these transitionary RDDs, do they actually persist in memory in some way if the clusters are still open?
Yeah, I believe they will. Yeah, unless I get like there must be some sort of garbage collection, but probably as long as there's a reference to them, they'll persist in memory. Meaning, like as long as you assign them to a variable, they'll persist in memory. And then once you close down the cluster, then they disappear, obviously. Right. Okay. And the other thing that kept coming up, I think these were really good questions, was just like how does Spark compare to other databases? I did my best to it actually ended up, like everything I do, it ended up being kind of long, but I did my best to create an outline of this. So this was kind of my answers to the questions we just did, right? And then in terms of how to organize this, I think actually PySpark, Snowflake, Athena, they all have similarities because they all use blob storage, meaning S3 or Google Blob, whatever it's called, Google Blob storage for long-term storage, right? So the main benefit of this is it's cheaper, right? We're storing it on Dropbox essentially, and don't have to pay for anything running, right? So it's cheaper. And then also more storage does not require more compute, right? They use partitioning to only select the data that matches a certain criteria. So you can still have determine your allocation of compute even if your data scales more. That doesn't mean the compute will scale in parallel to that. And then contrast with this with Postgres or Redshift, where with more storage we're paying for more compute, right? As we are storing more data on the database, we need to buy more computers effectively to do that. And I said okay, well then how do they differ in terms of this? Well, you can use partitioning with both PySpark and Athena and Snowflake. One difference is that Snowflake performs micro-partitioning for you off the bat. So Snowflake, I believe, will partition the data multiple different ways. And so when you query it, it will query the data using multiple different partitions of the data, whatever kind of is most eligible for it to use. Meaning, so if you partition, it will probably both partition by date for one column and maybe the alphabetically for another column. And then the other benefits are just data lake versus data warehouse benefits, right? So Snowflake of these three is our data warehouse, or uses a data warehouse model. PySpark, Athena, more data lake, right? And so now it's just what are the benefits of a data warehouse versus data lake? Essentially, the main difference is that this requires more structure, right? We have to actually load this into defined tables. So we have to create the table, transform the data to load it in there, and then we're good. With a data lake, we don't have to do that, but then as a consequence, it's less organized typically, right? Because part of the benefit is you get to store low value data, but then part of the cost of that is it can become like a junk drawer where you're just throwing everything in there and then it becomes disorganized, things like that. Sometimes you just have to use the data lake, right? Because of unstructured, semi-structured data. So we talk about this. It's difficult to use for less technical employees, right? You're basically just using Python or some back-end programming language to query it. Whereas with data warehouse, you can use SQL, and a lot of more people know SQL than know Python well. But then using Python is good. It allows us typically to do more fine-grained things. We can write functions and kind of complex code bases. And then data scientists, right? These ML libraries are written in Python. There's BigQuery ML, but it's still not so easy to use. And it's typically probably not. It's only used for generic type of things. Most of the most of the ML libraries are Python based, or have a Python interface. So that for that you basically are using, you're querying your data lake, not a database. And then if PySpark and Athena are both like this data lake structure, what's the difference? So one is, PySpark, you're managing a cluster of computers. So you kind of specify how large your clusters are. With Athena, you don't, right? It's like this serverless model where you pay per use, and that's like hidden away from you as to how many clusters are using underneath. Most people say like there's more robust queries and manipulation you get in PySpark. Like it has these ML libraries, which is why PySpark is often taught to data scientists as well, right? So it's like for performing ML operations on a large database or a large amount of data, right? PySpark is basically what most people are using for that. It's more of an in-memory strategy than Athena is. Athena uses Presto underneath. I don't know a lot about Presto, but it's not as in memory of a database. It relies more on the hard drive than something like Spark does. And then Athena only has a SQL interface, right? So you're not getting this like data manipulation as kind of fine grained as you do with Spark. Okay. So these are the difference. Typically, most people would just use Athena for, like, when, say, searching through, like, an error message, like looking through logs and then searching through them to find, like, the error messages or a particular error message to see what occurs, and then maybe moving all the error message data into, like, another S3 portion and then querying it from there. It's generally used for, like, initial kind of analysis, but not more in-depth analysis. But these are good. But even just seeing the comparisons between these three is worth doing. Is worth just like seeing. Oh, these guys are actually pretty similar, right? All three of these are trying to use blob storage for their long-term storage, so that reduces the amount you have to pay. And then the next thing to go through is just kind of wrapping up Spark. So for that, the main thing, like we actually covered the hard parts of Spark. If you go through that and, I'll give you time, if you complete that first section, that's really, like, to me, what there is to know about Spark is how it works under the hood. Because then the rest, oh man, I hope I did the Spark stop thing. The rest of it is the fact that it allows for a pandas interface and a SQL interface, both of which all right? So if you do, here I have a list of dictionaries. I can do spark.createDataFrame and then pass through this list of dictionaries. And then so this is creating a Spark data frame, meaning that underneath the hood we'll see it's a RDD. So now you call moviesdf.show. Show is your action, right? That's kicking off the job to basically perform like a select all. And here you can see it's distributing that. That was the stages. And now here we're seeing the data. All right. And then notice, this is pretty cool, right? Is the fact that just by reading the data, like we read in the data frame, it is performing, it's detecting the data types, right? This is a string. The index is like effectively an integer. This is also an integer, right? So that's a benefit. Like, I don't know, maybe Athena does that, but this is like a nice benefit. So this is called schema on read, right? You're not defining the data types like we would in Postgres or Snowflake. It's just detecting that this is what it is, right? But then the point is underneath, right? This is really just an RDD. So here's the map partition object that it created. And then, you get access to all of those RDD methods if you want. That's really what's occurring underneath. So when you call show, like we did here, really what's happening is underneath it's calling collect, right? Give me back the data set, the RDD. But so it has all the features of an RDD because it is just an RDD underneath. So I guess for me, it created 8 different partitions of the data. It's still lazy, meaning, if you do this moviesdf.select title, it's not actually executing the query, right? It's being lazy about it, and it's only executing it when you call something like .show at the end, right? This is our collect. All right, so it has all the features of an RDD. It's distributed, it's lazy, and then because of that, you only get to use, it's resilient. And remember that resilient strategy is the ability to reproduce the transformations. So that means you only get coarse-grained transformations, meaning transformations that operate on the whole data set. So you're not doing something like movies.df, slice the first 2 movies. That doesn't work, okay? You have to, if you want, you could, we'll see later on, you could filter by the ID or something like that. Like, that's okay. But you're filtering on the entire data set. So you could do like a filter down here. How do you do it, and then how do you do a filter? The same way that you do in pandas. Let's just do it over here. It'll be easier. So for instance, here's my movies.df. If we do moviesdf.show, we can see the data. And then I believe what we can do is, let's say we want to query based on the index. Remember how we do this in pandas? It's moviesdf : index. So this is like a select. And then say, where does it equal 1? So this is a filter. All right, let's make sure that works. And now what I'll have to do is .show, right? Because it's not actually executing it until I call the action, right? And now we're selecting based on that. And this is returning, right, a separate RDD, okay? Yeah, so this is returning a separate RDD to us. There must be a way. Let's do .rdd. Can we do that? Yeah, so you see that? Here's my map partition RDD. Okay, and then the other thing is just, you can also use SQL for it. So here you can see I'm loading the RDD, and then the step is this create or replace temp view. Give it a name. This is effectively giving you the table name. And then we have the schema. And then that's it, basically. You get your RDD, and then you say create or replace a view, right? Give yourself this view claims. And now that's saying I can now query this RDD, spark.sql select all from claims, order by, a column, and we can now query it just like we do in SQL. So just to go through that, and again, you have to end with show. .show, call my action. Otherwise, it's not kicking off the job. All right? So just to go through that again, you start with an RDD. You're creating the RDD, this data frame, but this RDD doesn't have a name yet to Spark. So then we say, I want you to refer to this RDD as the name claims. Now Spark knows to refer to this as claims, and then you can effectively query it. Select all from claims. And you just use Spark, like our database connection. We're going to use SQL, and then do select all from it, just like SQL, and now do the show to actually kick off the job. So the same thing, like we can chain these. So right, it's not performing this query until you do the .show. Right, that way if you chain these, it will figure out what is like the most efficient way to return to you what you're asking for. Is there anything else? Oh, and then the other thing I showed is you can call .explain at the end of this, and then you can kind of see what it's doing. It's performing a file scan of the CSV. It's giving us these partition filters, but this is like a way to see, probably like a bit of like those various stages outside of that Spark UI that we've been using. Okay, so you can see like the interface to Spark is things that you already know, pandas and SQL. All right. Right. That's why we spend so much time talking about how it works under the hood, because there's nothing to. I think like once you play with this a little bit, you'll be fine. All right. Cool. So review this, I'll put out, you have my notes. This blob storage DBs is my notes on it. And then here's the data frames material in the Spark and SQL. And then this part's a little bit more complicated. If you want to, I also think it's you can see that I just put it in the requirements.txt file, right? And then you can, create a new environment, and then, run pip3 install -r requirements.txt to install the required libraries. If there's an issue, just do pip3 install requirements.txt. Then the idea with Prefect, like part of like what they advertise about it is that it's supposed to feel like Python. Okay, so what you can see is that like we can comment out like there's nothing from the Prefect library in here. I've commented out the parts that we can add later. So this just starts at the bottom, get and write data and pass through a name. So it takes an argument of name. So this, we can see we call the function down here. So get and write data, pass through this. This is a restaurant name, and this will call find receipts, and that will hit the Texas Drinks Receipts API, make a request, pass it through this name, and then give us back the response. So this will, find receipts, give us back some JSON, and then data frame write to CSV receipts. I want to make sure I might already have it in here. Yeah, let's delete this. Okay. And then, how do you actually do this? Well, we can just run the script, right? And that will call get and write data, and that will call the remainder of these functions. So if I want to, we can also print the results if you want to see it here, but it will write it to CSV. So we do Python 3 index.py. Beautiful. Did I not return? I'm returning it. Oh, maybe this function doesn't return anything. That's the issue. It's okay. So, but you can see receipts are stored here, right? So it did retrieve it, right? I don't believe myself. Let's just do it one more time. Right, do Python 3, index.py. It did take a second, right? And then we have our data. So this is just, pure Python. And the idea is now if we start importing from the Prefect library, we're just importing two things. Flow is for workflow, and then a workflow has many tasks. And then what we'll do is we can decorate, this function to make it into a workflow. And then it calls the first task here, and then it will call the second task. All right, so first call the find receipts task, and then it will call the write to CSV task. And you can see what's cool about it is it can just easily reference the return value from one function to the other one and pass through a task. And now how do we invoke the workflow? You just call the same, you just do it like you would Python. So you just do Python 3, run the script that will call this function, which is a workflow, and then that will call these separate tasks. Okay, so notice, created a flow run called Fuzzy Badger, so it's giving that for the flow, get and write data, okay? And then it created a task run, find receipts, for the task, find receipts, right? And then it created another task run, write to CSV, related to this task. So you can see that now, right, we're getting this logging capability, and you can also kind of get a sense of the relationships, which is, a flow has many tasks, okay? And then in order to trigger it, you can imagine we have this on a schedule. So there are many flow runs, right? Each running, and each flow run has many run tasks, okay? And then what's also nice about this is because I'm logged in to Prefect, I'll show you that in a little bit, but I can go to prefect.io and click on it and click login. And you can see here are my flows, and that is this, what was it called? Get and write data. That's this one. Invoked now, 6:23 p.m. right? Which is my time right now. Okay, so it is keeping track of this. This was the Fuzzy Badger thing that we saw before. Created the flow run. So it is automatically hooked up. How is it hooked up? You do have to do this Prefect, I forget if it's auth login, And now let me stop recording for or pause.